P-values are one of the most misunderstood concepts in all of statistics, so in this video I'm going to give you a beginner-friendly explanation of what p-values actually are. I'm also going to go through some of the common misconceptions. A p-value does not tell you what the probability is that your result is true. So what is it exactly? First of all, every p-value starts with a null hypothesis. The null hypothesis basically assumes that there is nothing interesting going on. There is no correlation, the treatment has no effect, there is no difference between the two groups. You get the idea. So to make this fun and interesting, consider this example. Let's just say that a friend says to you that he can tell the difference between Pepsi and Coke. In this case, your null hypothesis is simple. He can't tell the difference between Pepsi and Coke, and he's actually just guessing. In other words, there's nothing interesting going on. If this null hypothesis is true, and in other words, he is just guessing, this means that he, in theory, would be correct 50% of the time. So you decide to put him to the test. You conduct an experiment. Basically, you present to him a glass of Pepsi and a glass of Coke, and he has to taste both of them and tell you which one is which. And then you repeat this multiple times. So in other words, you have multiple trials in which he is telling you which one is which. At the end of the experiment, you find that your friend correctly identified the drink 60% of the time. Now, here comes the big question. Is that 60% impressive? Or is it the case that he actually might have scored 60% just from guessing? In other words, is it possible that he got that score of 60% just by random chance? This is where the p-value comes in. A p-value asks, if the null hypothesis were true, in other words, if your friend really can't tell the difference, how likely is it that we would see results this extreme or more extreme? Now, when I say this extreme or more extreme, I am referring, in this case, to a score of 60% or higher. In this case, the p-value is 0.03. That means that if your hypothetical friend really was just guessing, for him to get a result of 60% or higher, well, that would only happen about 3% of the time. How do we interpret this exactly? Well, because 3% is quite a low probability, that means that it is quite unlikely that your friend would have obtained a result of 60% or higher, assuming that he actually was just guessing. Because this seems quite unlikely, that allows us to start doubting the null hypothesis. Importantly, we then compare our p-value with our defined alpha level. Now, alpha is typically set to 0.05, and how it works is this. If your p-value is less than the alpha level, so in this case, if it is less than 0.05, then you say that you have a statistically significant result. 0.03 is less than 0.05, so in this case, we can say that this result of 60% is statistically significant. But let's talk about what this p-value doesn't mean. It doesn't tell us about how amazing your friend is at telling the difference between Pepsi and Coke. It just tells us that his result of 60% was probably not due to random chance alone. And that's something that we really need to emphasize, that sometimes you do obtain a result purely by chance. In this case, it's possible that your friend might have just been guessing and managed to get a score greater than 50%. So to sum it up, the p-value is not the probability that your friend can tell the difference. It's not the probability that the result is true, and it's not the probability that the null hypothesis is false. It's only about how surprising the data would be, assuming that the null hypothesis is true.